All right, let's take a look at the zero product property. What it states is that if I have two values being multiplied together and their product is zero, either that A or that B has to be a zero. Makes sense, right? So why do we need to know this? Because what we're going to do here in this example is we're going to use the zero product property, which states that if I've got a polynomial in factored form equivalent to a product of zero, we can use the zero product property. You see it in this case, two different polynomials multiplied together making zero, two binomials here multiplied together making zero, and two binomials here multiplied together to make zero. So what do? We use the zero product rule, right? It tells us that either A is zero or B is zero. 0 times 6, that would work. Or flip-flop it, 6 times 0. Okay, one of those values has to be a zero. And because of that, what we can do is we can take each part, 2x, set that equal to 0. We could say it could be this part that's the 0, or it's this binomial, x minus 4. That's the 0. So those are our two equations that we can set up, and then we solve each one of them. So if I just divide by 2, I'm going to get x equals 0. That is one possibility. My second possibility is plus 4 cancels plus 4, x is equal to 4. So that's all we're doing is you're going to take each part, right? Look at this as your A, look at this as your B. There's two separate expressions. Each of these in this case is a binomial, 2 terms times 2 terms, okay? Think of them as two different parts. A times B equals 0. Either this is the 0 or this is the 0. So set each one up. 2x plus 7 equals 0 and solve that. Or you could say 2x minus 7 equals 0 and solve this. So what we're going to get here in this scenario is minus 7. 2x is equal to negative 7 divided by 2 divided by 2. X could be negative 7/2. And you might notice something over here, right? Just because this is plus and this is minus, all that's going to change is here I'm going to have a positive 7. So when I go to divide by 2, x is going to be positive 7/2. So what we call these are our roots. So in this case, our roots would be 0 and 4. Okay, those are our two possible values of x that could create a 0 as a product. Over here, our two values for x would be a negative 7/2 or a positive 7/2. Okay, this one here, x minus 3 times x minus 9. Well, we're either trying to make a 0 there or we're trying to make a 0 there. We could probably just mentally think of these values, but I'm going to show the steps for you, right? If I just look here, what number would have to be there for x to turn this into a 0? Well, something minus 3 makes 0. It's very clearly a 3, right? But if you wanted to show the work, you just set it up. This is your A, this is your B. Remember, A has to be 0 or B has to be 0. So all that means is if A is this, right, x minus 3 equals 0, and then you just solve. Plus 3 plus 3, x is 3. There's one of your roots. B, x minus 9 has to make a 0. Plus 9 plus 9, x could also be 9. So roots of 3 and 9, roots of 0 and 4, roots of negative 7/2 and positive 7/2. That's the zero product rule, right? Something times something else equals 0. Yeah, one of those values has to be a 0.